Okay, it's an optional question, and it wants you to integrate. Here's the integrand from 0 to 1. So if you look at the integration would look like this over here. All right, we'll get to that in a moment. Um, I want to point out that this is it appeared in the past on exams. It doesn't appear anymore, but it appeared on what I called exams that are difficult, and they're difficult for people that don't prepare for these exams. If you prepare for the exams, though, and you're lucky and you see things that you know in the exams, they tend to be straightforward. It's difficult, though. Like if I were looking at this and I wonder how to proceed with it, and I'll go through that with you. It's not an easy thing to do. The integral is also, famous. It goes back to 1819, and you may want to read through these footnotes, by the way. By the way, the two exams we're talking about over here, Putnam, and the other one's going to be an entrance exam that's used in India, and that's the IITJEE exam, all right? But anyway, be aware that good students may spend an inordinate amount of time doing all types of wacky integrals. And I consider this to be a wacky integral, by the way, all right? Now, certainly it makes it, for them to do integrations, they go much faster at it, and they're really good at it, by the way, right? But if you're not spending much time in this, everything looks difficult. But I will say this, though, the steps that follow here, you know about all the steps, by the way. Every single step you know, right? You know every single step over here. So let me point out what I did over here. And certainly it's not unusual. I made a substitution, and the substitution I made was, x equals tangent theta, dx, I know the derivative of tangent, secant squared, yada, yada, yada. I also know this basic identity over here. And then I rewrote the integral, all right? So let's go through that, and let's see. If the lower limit is 0 in the x land, so if x equals 0, what would it be? Well, that would be 0 equals tangent of theta, and theta would be 0, all right? And the other one is x equals 1, and 1 equals the tangent of theta. So the upper hand limit there would be pi over 4. All right, then I did kind of, just put everything in now. So it's going to be natural log of, let's see, it's x plus 1, so it's going to be tangent theta plus 1. And on bottom, what would you get? Well, let's see, you get x squared, which is tangent squared now. Again, we're going to the land of thetas, plus 1. And now I got to multiply by the dx then. What's the dx in the problem? Oh, secant squared, theta d theta. And immediately what I notice over here is that the bottom here and this over here are identical. And I can cancel those two off, by the way. All right, so when you cancel those two off, what would you get? A pretty simple integration, by the way. And you get this over here, 0 to pi over 4, the natural log, the tangent theta plus 1 d theta. All right, let me show you where that's written. And we're over here now. And again, we're kind of proceeding, forward on it. So let me kind of erase the past now. We're done with this, and I want to move forward. All right, let me erase the past. All right, and I'll move forward this over here. I'm looking at this over here, and again, I'm still in that situation. What do I do with this? And certainly one of my recommendations, pre-calc students, is rewrite the tan in terms of sines and cosines. So let me do that over there. So tangent of theta plus 1 would be the same thing as sine theta over cosine theta plus 1. And I'm going to bring those two terms together now. That's cosine theta, sine theta, plus cosine theta. All right? Let me show you where that's written. That's written right over here now. And then I kind of use my rules of logs to split into two integrations, all right, or two integrands. So, it's really not that bad. I mean, I'm over here now. The natural log of the top minus the natural log of the bottom. Just simple rules of logs, by the way. Then I'm sort of like saying that the thing looks like it's getting worse and worse and worse. But I'm still looking at it, and I want to proceed forward. So I'm going to say most students would be stuck here. They'd be exasperated. They wouldn't know what to do. They'd be in exasperation at this point. But I'm going to say I need to move forward. So what I start to realize is that this over here, right, this over here has something to do with a sum formula. So I would say, what sum formula? I'm going to say probably, if I see in sines and cosines, I'm going to say probably something to do with cosine, all right? And by the way, I'm hoping for it. I'm hoping to get a cosine over here, all right? I'm hoping to get this thing in terms of cosine. Hoping for it. So let's take a look at it. And, write down, cosine of a plus b. That's a pretty well-known one, right? And then I'm going to select the b to be minus pi over 4. You may wonder why that is. I got a limit over here. And let's see what happens. All right, what do you get over there? Well, the cosine, that's pretty simple. get this, you get this, you get this, you get this. Just plugging it in. And what do you get over there? Well, it's pretty easy to evaluate this over here. So it's cosine of A, and the cosine of minus pi over 4 is just 1 over root 2. So I can put the root 2 over here. And then what do you get? Let's take a look. You get minus sine A, and then the sine of minus pi over 4 is minus 1 over root 2. So I get something that looks pretty simple over here. I get cosine A, let's see, plus sine A over the root of 2. And what's that equal to? That's equal to the cosine of A minus pi over 4. So what do you do now? Multiply both sides by root 2, and you get this over here. All right, fairly straightforward. Let me show you that's written right over here. All right, so again, we're moving forward now. What do? I take that original integral. I mean, we were here before, and now we're here. All right, what did I do over there? I used this. Let me write this down for you. So I really want to know, cosine. Let's see, I want to know cosine theta. I'm not cosine, I'm sorry about that, I'm misreading. I'll point out what we're looking for. We're looking for this over here. So sine of theta plus the cosine of theta, and I'm using this over here, is equal to the root 2 times the cosine of theta minus pi over 4. All right? So I just write that down. All right? And it's right over here. All right? Then what do you do with that? I kind of look at it again. I'm going to do the rules of logs again. And, I'm going to split this into the log of natural log of 2, this one, and this one over here. And then I'm starting to realize that I'm seeing something that looks, something familiar. I mean, I've seen that, natural logs of cosines, natural logs of cosines. So I split into 3 integrations. The first one being super easy. This one over here, not so bad. I couldn't do it, though. And this one over here, not so bad. But I still can't do it. I can recognize they have similarities. So between these two have similarities here. They're similar. All right, they're similar. We'll go through that. This one is just really easy, though. It's easy. Right, that's too easy. All right? But what I'm going to do over here, I'm going to look at this integration here. Let me get my eraser out now. And I want to tell you what I'm going to focus in on. I'm going to focus in on this guy over here. And I want to get it to look like this guy over here. And a way to do that is to make a substitution. And a substitution I would make over there, I would make the substitution probably u equals theta minus pi over 4. Again, we're working on this guy over here now. And if I were to write that down, what would I get? I would get, land of x's. I want to go back to the land of u's. You know what? I noticed I made a mistake over here. And I have to correct it. This really shouldn't be an x. It should be a theta. Let me see how many times I did that. So let me just outline that for you, and I'll correct that. You're not going to see that in your notes, by the way. All these things over here should be theta. That will be corrected, and I apologize for that. So let's take a look at this over here. So, and again, this should be a theta too. All right, we'll correct that. So we're going to go to the land of u's now. What are you going to get? Minus pi over 4. Whoops. And that's going to go to 0. And then you're going to get the natural log of the cosine of u, and that's going to be du now. Fairly simple, all right? That's right over here. Now, what I know about the cosine function, it's even. So, whether you're going from minus pi over 4 to 0 or 0 to pi over 4, it's going to give you the same result. So I wrote this down. And this is where I have the eureka moment that I'm looking at, this integration over here, and I realize it's identical to this integration over here. All right? What else about these two over here? Whatever they are, whatever this number is, it's the exact same number as that, and we're subtracting them. So I'm left with the real simple integration now. And by the way, I got to correct my differentials in all the problems, by the way. And what I mean by that, those x's are going back to thetas again. All right, let me outline that for you. Theta, 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 theta. All right, sorry about that. And this is also a theta over here. And let's, my eraser, erase this over here. And I'm going to point out, this is really easy to integrate. All right, easy to integrate. What do you get over here? Well, you get the natural log of the root of 2, and that would be theta, and the limit integration can be from 0 to pi over 4. What do you get over there? The natural log of root 2. Then you get pi over 4 minus 0. Well, that's pretty simple. The natural log of root 2 is actually going to be 1/2 the natural log of 2. And this is going to be pi over 4. And what would this give you? This will give you pi natural log of 2 all over 8, which is what we have listed over there. Again, I got to make some small corrections over here. The corrections are the differentials. You may wonder why that happens. It's basically a copy-paste error on my part, that I don't bother to edit my copy-paste work. All right, I reuse code. That's what happens there. All right, thank you so much for paying attention.